All right, good afternoon. I don't know about, oh, am I still muted? No. You can hear me, right? I don't know about you guys, but Wednesdays are really long, having to go to all the classes, so I know how you feel. Just a reminder that I am sending out progress reports on Friday. So it does not necessarily mean you're failing. If you have more than 2 absences, missing more than 2 assignments, or getting low test grades, I'm sending out a progress report, basically saying, wake up. If you don't straighten up, you could possibly fail. Also, I need you to look at Zangle and make sure everything's right, because I've had students taking me every which way, but and when I'm under that much chaos, something could get messed up. So make sure that your grade looks correct. If not, let me know and we can take a look at it. Also today, I'm going to go over how I want the scratch paper done, considering that I'm not going to be looking at garbage anymore. So the first thing I want to do is I want to look at the post that I sent this morning. So I want to make sure we understand it. So I'm going to share my screen. If you're not muted, could you please mute yourself? Okay, hopefully you can see this. It says on Tuesday, we're going to take exam 6162 at 8. You will enhance your overall grade if you do well. You'll have 60 minutes to do the exam and 15 extra minutes to submit your scratch paper to justify your work. So there is plenty of time to write the problem, work vertically and circle your answers, and submit your work. So there's no excuse for turning in anything late. In order to get credit for the exam, your scratch paper must be legible and formatted like an assignment. So once again, I'm going to go over the assignment that is specified in the syllabus and what I went over at the beginning of the year. For each given exercise, you must write the original problem, you must show your work, and circle the answer or answer. Your take an exam earlier, however, you may not take the exam later without explicit teacher permission. So with that, let me stop sharing. This is what your assignment should look like. This is what your scratch paper should look like. You have a piece of paper, right? On the outside, you should have your name, date, period, and exam 61-62. When you open up the paper, I should see problem number 1 with the original problem, work vertically with the answer circled. Every single problem should look like this. So number 2, number 3, when you run out of room, come over to the second column, number 4, 5, 6. When you're done, you can get another piece of paper. You can just turn it over and continue with 7, 8, 9, 10, 11, 12. Then get another piece of paper if you need it. This paper must look like this. If it doesn't, I'm not going to look at it and I'm not going to give you credit for the exam. So I'm just letting you know that no more garbage, no more I can't see what you're doing, no more over 12 hours trying to figure things out. The scratch paper must be legible. The problem must be written, the work shown, even if it's a graph it, and this answer. So does anybody have any questions about what an assignment or your scratch paper should look like? All right, what you see on the board is problem number 11 in lesson 6.2. So I need to copy this down and then I'm going to finish the problem. So all of this stuff up here is what's in the reading. So when I tell you to write the original problem, I don't expect you to write 1,000 words. I expect you to pick out pertinent information in the problem, not spend an hour writing everything out. So as I read this problem, This is the information they're giving you, and they're going to want this. All right. Now, what I did is I found K. So we're going to find U together. So let me read the problem. This is number 11, in lesson 6.2 on page 2. It's a physics problem. An object thrown in the air has a velocity, which is speed, after t seconds that can be described by v in meters per second, and a height in meters. The object has a, which is weight, of 2 kilograms. The kinetic energy of the object is given by this formula, and the potential energy is given by this formula. This is 9.8 times m times h. They want us to find an expression for the total and potential energy, which is K plus U. So what we're going to do is we're going to find K, we're going to find U using the U formula, and together with the sum to find the expression that they want. So it says to find that expression as a function of time, and then they want to know, what does this expression tell you about the energy of a falling object? So I'm going to wait for you to write this. And so just write everything down. Do you guys need more time?
I wrote it down now.
Okay. Okay. So what we're going to do now is we're going to find U, which is 9.8 times m, which is the weight, times h, which is negative 4.9 t squared plus 24t plus 60. So remember what I said about putting monomials in front. So what I'm going to do is, well, I'm going to have you multiply this out, and then we're going to distribute it to the quadratic trinomial. So what's 9.8 times 2?
19 points.
Okay. So this is negative 4. Okay, thank you. Okay, help me out with this, please. What's 19.6 times 4.9? We know it's negative. 19.6 times 4.9.
96 point.
T squared. And a positive times a positive is a positive. What's 19.6 times 24?
470.4.
For 70.4 T. And what's 19.6 times 60?
1,176.
Thank you. All right, so what we're gonna do is we're gonna find the expression that they asked for, and I'm just gonna stack it. So it's gonna be 96 up here, 04t squared minus 470.4t plus 576, and we're gonna add it to negative 6.04t squared plus 470.4t plus 1176. Do you notice anything about this? So we end up with a constant, which is what, 12, 5, 1752? $17.52. So they asked us, what does this expression tell you about the energy of the falling object? Now remember what we found. We found K, which was kinetic energy, and we found U, which is potential energy. So what did that tell you when we added it together? Okay, since the sum is a constant, this means that the energy of the object is constant, and that as it gains kinetic energy by falling, it loses the same amount of potential energy. I'll read it again. Since the sum is a constant, this means that the energy of the object is constant, and that as it gains kinetic energy by falling, it loses the same amount of potential energy. Okay, what we're going to do today, you guys, is we are going to spend the rest of the period working on our teams. We're going to actually go into the teams, and a person's going to volunteer to share your screen on my HRW. You are to go into the evaluate section on lesson 6.2, and you're going to work problems. And these problems can count as the evaluate on your assignment. Excuse me. So what you're going to do is you're going to act like you're taking a test. You're going to write down the original problem, work vertically, and circle your answer. And then the person who's sharing their screen is going to input it to check it online. You're going to work as many problems as you can in the evaluate section of your text. And you're, rather than taking like an exam by yourself, you're in a team, acting like you're taking an exam. Are there any questions about what I want? Okay, class ends then at 2:05. And we will stay in those teams until 2:05, working the problems in the evaluate. So when you get into your teams, I need one person from each team to share your screen in Google Meets and get into my HRW, the interactive student textbook. See you in the teams.